In this lesson, we're going to look at a simple algorithm for doing a linear search. And a linear search is simply starting at the first element of an array, or really any data collection, and moving down element by element, searching for a particular item. What we'll do in this particular lesson is write a method called min, or minimum, which will find the minimum value in an array, which is the same thing as searching for the minimum value. But you can use this algorithm to search for any item. So let's get started. We're going to call this program linearsearch.java. And we'll skip a space, so I'm going to come back to write our method in just a minute. So I'm borrowing the main program from the quicksort lesson earlier, just so that we can use the array. We'll change a couple of these things. Actually, we don't need the middle part at all, so let's get rid of all of that. Really, all I wanted was the array. So let's write our minimum method. Public static int min, we'll call it min to save a little bit of space. And it's going to take an array as the argument. And what we're going to do is we're going to start the search by assigning the first array element as the minimum value, just arbitrarily. And then what we're going to do is we're going to work our way down the array until we've searched or looked at every element in the array and swap out the values if we find one that's less than the one that's originally assigned. So here's how we'll do that. We'll say for int I equal 1, I less than array.length, I plus plus, if array sub I is less than minimum, then minimum is equal to array sub I. That's all we have to do. This is a very, very simple algorithm. Then we'll return that as the return value for the method. So we can use it in our program like so. We have our array set up, and we can say int minimum equals min data, and system out print line. The minimum value is plus minimum. And that's all we have to do. Let's save it. Compile it. And then run the code. So what happens is that, of course, if you're looking at the array elements here, 5 is assigned to minimum first. Then it looks at 10. It says, is 10 less than 5? No. So then it moves down to the next element, 1. Is 1 less than 5? Yes. So now minimum becomes 1. Then it looks at 9, 4, 8, 3, 6, 2, 7. And you see at no point are any of those values less than 1. So 1 becomes the minimum value. Again, we call it a linear search because we're working sequentially down through the array element by element in a linear fashion. It's a very simple search method to implement, but the problem with it is it's not very efficient. Imagine we had 5, 10,000, 100,000 elements, and the minimum value is way down in the data set. Well, it's going to take a long time to reach that value. So there is a faster way to perform a search, and it's called a binary search, and it works on a sorted data set. Notice that our array in this example was not sorted. The binary search works only on sorted data, but it's quite a bit more efficient, and we're going to look at how to implement the binary search in the next lesson.